Hello, and welcome to the Norfolk State University Scene Show. I'm Professor Levy, and this is the first episode of the Tool Time video series. Today's topic is going to be lumber, marking, and measuring. When I talk about lumber, I broadly categorize it into two different groups. The two different groups are stick goods, which this is an example of, and sheet goods. This is an example of a sheet good. The first stick good that we are going to talk about is a broad category called 1x. 1x is the term which we use to talk about all the different sizes of 1x. This is a piece of 1x6, but we also have 1x4, 1x6, 1x8, 1x10, and 1x12. Lumber gets more expensive as it gets wider, but it is also used for different applications. If we take a tape measure to this piece of 1x6, we're going to find that it is actually 3/4 of an inch by 5.5 inches. This is the difference between nominal and actual dimensions. What do we use 1x for? 1x, when we buy the expensive, nice pieces, can be given profiles to look like molding, which we can use to decorate staircases. We can make molding go around windows and different architectural items. But the most common use that we have in the theater for 1x is building flats. Flats are what we use to represent walls. Now we're going to move on to 2x. 2x comes in the same varieties that 1x comes in. This is 2x4. If we take a tape measure to the piece of 2x4, we find out that it is 1.5 inches by 3.5. Again, these are the actual versus nominal dimensions. Nominal meaning the name that we call it. We have 2x4, 2x6, 2x8, 2x10, and 2x12. The most common dimension of 2x that we buy is 2x4. 2x4 is what we use to build stud walls and platforms. Platforms are what we use to represent surfaces in the theater. They are structural enough to hold people's weight, and people can run around and bounce and dance on them, and they support the weight no problem. There are wider and thicker varieties of lumber. 4x4 would be an example of that. We have a few pieces of 4x4 in this shop. Generally, we use them for architectural details, but we could also use 1x and build it up to look like it's a piece of 4x4. 4x4 is a lot of wood, so obviously it's more expensive to buy, and we try to keep our costs down. So that is a brief overview of what stick goods are. Now we're going to move on to sheet goods, which I have some examples of the different sheet goods that we have in this theater here beside me. In my hands here is a piece of plywood. I'm going to grab another piece too. This is also a piece of plywood. And another piece. This is also a piece of plywood. Plywood comes in many different varieties and many different costs. This is 1/4 inch thick plywood. What makes plywood as amazing as it is its grain structure. Plywood is a series of laminated shavings of wood. So this is all one veneer. This has 3 veneers to it in the 1/4 inch thickness. The grain direction, I don't know if you can see, but the grain on this plywood veneer runs this way. If we took this veneer off, the grain on the veneer below would run this direction. And then on the back side, on the 3rd veneer, it comes back to running vertically again. This crisscrossed grain pattern is what gives plywood its strength. This is 1/4 inch plywood. This is 3/4 inch plywood. I'm not sure if you can see, I'll bring it close to the camera. This has 5 different veneers to it, and 3/4 plywood is extremely strong. Now, again, 3/4 inch plywood, or all plywood rather, comes in a variety of grades and finishes. These are both 3/4 inch plywood, but this is a much more expensive sanded plywood with a much smoother, prettier finish to it. Sheet goods are what we use to face and lid. So the lid of a platform is what you stand on. The facing is the vertical surface that the audience would see, so it's how we make objects appear solid that are not solid. We use the 3/4 inch plywood for the lids because it's stronger and it goes on top of 2x4, which makes the frame of that platform. Now I'm going to take you on a tour of the scene shop, starting from the loading dock outside. We have these steel roll-up doors, and now we enter the scene shop. That's the loading door onto stage, which I'm going to close now. Looking at the stage is going to be a different day. Those are the steps coming down from the costume shop. Our work tables, dust collection. I'm going to close the roll-up door to the outside. Now you see our table saw. This is a rack for some shop-made jigs that I have. Over here we have our flammables cabinet and paint sink. And the first of our sheet goods racks. This rack over here is the one that I use for materials that are not as thick as 3/4 inch plywood. Mostly I have 1/4 inch Luan. I also have some 1/4 plywood in here, and then the sheet goods that you see with the black grids marked on them, that's OSB, which stands for Oriented Strand Board. Here we have some of our stationary power tools, the bench sander and bandsaw. Over here is the sheet goods rack for 3/4 inch plywood. Our air compressor here in the corner. This saw is our steel saw. This saw is our compound miter saw for cutting lumber. Up here is stick goods storage. Below the saws, I've utilized for sawing small pieces of 2x4, and below the offcut table for the table saw is the storage for long pieces of 2x4. Okay, the next thing I want to talk about is measuring and tape measures. Here in front of me, I have laid out a tape measure. Here is the tape measure that I have laid out. You can see down this end, there is a piece of metal that is loosely attached by these 2 rivets. This is to allow you to measure from the outside of an object, the outside of an object, and get an accurate dimension, or from the inside of an object and get the same measurement. It allows the steel tip to move. The tape measure is then divided into inches, which are the numbers from 1 through 12 that you see. At 12 inches, which is the same as 1 foot, the numbers increase in their inches, but they also start again up the top here in red. This helps you understand that this is inch 1 through 12, then it's 1 foot with the same corresponding inches 1 through 12. Back here at 16 inches, we see that something interesting happens. The number 16 is encased in a red box. This is a common framing measurement, 16 inches. This number 16 with the red box repeats itself at 32 which is 16 inches further down from 16 inches. The next measurement that would be in this red would be 64, which is beyond what I have rolled out in the tape measure right now. Each inch, I'm going to zoom in on an inch. Every inch on the tape measure is divided up the same as every other inch. We're going to concentrate on the inch between 30 and 31. There are 15 lines between 30 and 31. These lines all correspond to different measurements on the tape measure within that inch. Again, every inch is the same. We're just going to talk about the one between 30 and 31. The biggest line in the middle of this inch, this one here, is the half-inch mark. So that's 30 inches. This would be 30 and a half. 30 and a half plus another half inch would be 31 inches. Each of these lines actually represents a 16th of an inch. So that's 1/16, 2/16, 3/16, 4/16, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and then 16. If we think about fractions for a minute, even though these are all 16ths, they can all be simplified except for the odd numbers. 2/16 would be an eighth of an inch. 4/16 would be a quarter of an inch. 6/16 would be 3/8 of an inch. 8/16 would be a half inch. 10/16 would be 5/8 of an inch. 12/16 would be 3/4 of an inch. 14/16 would be 7/8 of an inch. And then 16/16 is a full inch. This is the same for every inch on the tape measure, like I said before. So if I move the tape measure down some, and we look at the inch between 35 and 36, you see it's broken up exactly the same way, and all the markings and designations are the same. The next thing I would like to briefly touch upon is a few things with the tape measure that I think a person should not do. And these things start with the tape of a tape measure is actually metal. So you want to be very careful when you close it, not to run and stop it with your finger, because then you can cut yourself. The other thing that I think is very important with a tape measure is to take special care of this tip that moves. If you let the tape measure slam closed, it's going to over time wear on this little connection here and make it so that the tape measure no longer reads accurately. Okay, so we have talked about the tape measure. I want to move on to a couple of things that we use for marking. We now know what the designations on the tape measure are and what they mean. Now I want to illustrate how we use the tape measure and some devices for marking. I'm gonna put the tape measure down here. This is called a speed square. It's used in the construction industry for obtaining roof angles. It's marked with, I'm trying to get it on film here, the degrees for pitch and rafters. We use a speed square for marking lines and 45-degree angles. So this is a right triangle. In here is a 90-degree angle. This is a 45-degree angle. We use this for marking either one of those, a 90-degree or a 45-degree. If we're going to mark a different angle, I'm going to use a different tool. The tool that I use for marking varying degree angles that are not 45 is called a bevel gauge. And it is this knife-like instrument here where the ruler comes out of the wooden part, and we can set it. The angles aren't marked, so if you were trying to find a specific angle, you would most likely have to use the chop saw first to determine what your angle is, set your bevel gauge square from the fence to the blade. So now what I'm going to do is show you how to mark some angles on the piece of wood and how we would use that information to then make the cut. I'm going to take my tape measure and I'm going to make a mark at, say, 6 inches. The way I like to do it is to measure both sides of the tape measure and put a mark. I think you can see that. Yes. So then I'm going to take the speed square. I'm going to line the edge of my speed square carefully up with those 2 lines, and I'm going to draw a nice clean line through both of those marks. What I like to do is rotate the pencil slightly while I'm pulling it across. That way, if there are any variations in the tip, the lead of the pencil, it creates a nice skinny line so that we know where we're actually cutting. Also, I like to indicate on the board what side of the line that I just measured I want to cut on. This helps me for 2 reasons. It lets me acknowledge in my head that the blade, and I'll show you this in a few minutes, on the saw, the blade actually has width to it. So if we were to cut directly on top of that line, we'd actually be cutting a little bit on either side of it, and that's not what we want. So because I have marked my line with an X, I know that the side of the line that doesn't have the X on it is the 6-inch piece of wood that we want to keep. So the X side is our scrap side. We could do the same thing with a 45-degree angle, and I'm gonna put our 45-degree angle into what we just measured here. So the speed square has this raised side on it, so it sits flush to the edge of the piece of wood. So I'm going to put that hard against the lumber, and again rotating the pencil for that clean line. I've now drawn a 45, and I want to get rid of this side, so I'm going to mark it on that side. The other instrument for marking was our bevel gauge here. So if I set it like that, I know that's my 45-degree angle, but I want to cut a different angle. So I'm going to mark this one. And that's how we would use the bevel gauge to indicate what we're trying to cut. The next tool for measuring and marking that I want to illustrate is this, the framing square. We use the framing square for multiple things, not just marking. We actually use it for making sure things are level. If we're installing a platform on the ground and we want to make sure that the top of the platform really is where we want it to be, and it's square, the legs are perpendicular to the floor, we use this to make that square. But the other thing we use the framing square for is for marking sheet goods. One of the things that I like a lot about a framing square as compared to the speed square, both are great tools for marking and measuring and making sure things are square, but the framing square is a lot larger than the speed square is, and so it tells a better story. If we're marking out where a set is going to go on stage, this is going to tell me a lot more information about whether something is square and running in a straight line than this is. This tells me about 10 inches, whereas this tells me the story over 2 feet. So what I'm going to do is we're going to put a mark at 12 inches, and then I am able to use the square, and I just line the edge up to the edge of the sheet good, and I draw my line down it. If this was larger than, if the line that I needed to scribe was longer than the 2 feet of the framing square, I might make several marks along the piece and use one of my long levels, which tells me about 3.5, 4 feet of the story. If it was longer than that, I could get a nice piece of lumber and use the piece of lumber or steel to scribe something up to possibly 20 feet or so. But you want to make sure that what you're using is perfectly straight. Okay, the last thing that I want to demonstrate for you guys today is how to mark an angle or a circle that is bigger than a compass. So I'm going to show you a shop-built method to make an arc or a circle. So the last thing that I want to illustrate for you today is how to mark a radius or a circle that is larger than a compass that you might have on hand. So this is really pretty easy. What we're going to do is we're just going to draw ourselves a line on our piece of lumber right there. Then we are going to take the tape measure, and we need to know the very middle of this piece of wood. So we know that this is a piece of 1 by 6, which means that it's really 5.5 inches across. So we're going to put a mark at 2 3/4, which is the middle point of this piece of wood. This is easier for us because we are making up the radius that we are going to draw. I am going to put a mark 1 foot from that line. So I draw a line, and again, we're going to find the middle of that, which, because this is a 5.5 inch board, we know it's 2 3/4. So we have our two middle marks. This will allow us to draw an arc or a circle with a radius of 1 foot. So I'm gonna step off camera for a minute and grab my impact driver and screw gun. So these are the tools that I'm going to use to turn this into a compass. We have this one, which is an impact driver. It uses a ratcheting motion to drive screws, and this is a screw gun or a battery powered drill. So what I am now going to do is take my impact driver and my screw, and I'm going to drive that screw through the first center mark that we made, and then I'm going to take the screw gun and drive a hole through the second mark, center hole that we made. Then I am going to grab a pencil. My drill bit's a little bit big, so I put a little bit of tape on the pencil so it's easier to make it stick in this hole. And there we have it. I can now draw my radius with this compass that we have made. That might be a little bit hard to see, but there we have a 1 foot radius